Yeah, that's what they said. Okay, so we had compressed air technology. More specifically, we're going to be delving into compressed air energy storage systems, but we'll also be taking a brief look at compressed air technology as a whole. So what is a compressed air energy storage system? Compressed air energy storage is a way to store energy that was previously generated for later use, such as with wind power or with solar power, and it stores this energy as potential energy, and it saves it for off-peak hours or whenever it's needed. So it's a way to store unused energy when wind stops blowing and the sun goes away, and we don't have any other source of clean, renewable energy.
So before we delve into how compressed air technologies work, let's first talk about how air compressors work. So basically, there's two parts of an air compressor. Basically, there's a supply side, which basically takes in the air, and the demand side, which basically tries to compress the air and make sure that it doesn't either escape. Okay. So there's basically two types of air compressors, which is positive displacement and dynamic. So for positive displacement air compressors, those are basically the storage. They compress the air when the air is basically trapped inside of it. Right. Basically, it just lowers the volume of the air and adds pressure. And the dynamic doesn't hold the air; it doesn't squeeze the air off. So it's sort of like a vacuum or any type of closure. Yeah.
Thanks, Jeffrey. So that's how an air compressor works. But then so we want to move from an air compressor to how these compressed air energy storage system works. So there are several methods by which we can improve the efficiency of an energy system, of a compressed air energy system, by regulating the temperature, right? Because pressure and temperature are proportional to each other. So if I increase that pressure, I'm going to increase the temperature. But over time, that temperature will dissipate. And that's going to lead to a more inefficient system if that heat is wasted. So we want to come up with ways that we can preserve the heat and add it back to the air as it is expanded. So that way we can drastically improve the energy efficiency of our compressed air energy storage system. So there are four types. The first is adiabatic, in which the heat is preserved in some sort of fluid, like oil or molten salt, which have a very low radiant thermal conductivity. And it returns that heat that's stored in, say, the molten salt as the air is expanded to improve the efficiency, increase the velocity of the air, and run that turbine. Diabatic is the opposite of this method, in which, well, not necessarily the opposite, but the heat is dissipated. It's not stored by means of any material like oil or molten salt. And then the air is reheated after expansion, so after it leaves that compressed state, by a source like natural gas, which is obviously non-renewable. So that leads to an energy efficiency of about 27%. The third method is isothermal, in which the operating temperature is maintained by means of a heat exchanger. So the current heat exchanger technology isn't optimized for something like this. Usually they're using like a vehicle or something. So compressed air energy storage systems by means of isothermal can only operate at low power levels, but the energy efficiency is very, very good. And near isothermal is a method in which the heat is conducted to a large mass, or a large thermal mass that has a low thermal conductivity, and the operating temperature is maintained that way. So that's also very efficient, about 9%. So that's great. We have this compressed air energy storage. We're going to take this electricity, convert it to this potential energy in terms of pressure. But how does that address global change, the climate warming? Well, like Braden mentioned at the beginning, right? Renewable sources as a whole are highly intermittent on average, something like solar, right? What if it's cloudy outside? You don't get the same effect. What if the wind's not blowing? You don't get your wind energy, right? So we need some way to store that energy, right? And that's how compressed air energy technology converts electricity into stored energy, right? Obviously, there are other systems by which we can do that, for example, like a battery, but we'll talk about that a little bit later. On another note, another compressed air technology that we'll talk about is a pneumatic engine. And that could, say like an air-powered vehicle, could reduce greenhouse emissions from transportation. So Jeffrey, if you wanted to talk about that a little bit more.
Yeah, so aside from there's multiple types of compressed technology. So we have renewable energy storage and pneumatic motors, which are kind of the ones we're going to talk about. So hybrid vehicles and compressed powered cars are essentially they use basically compressed air to basically move. So for compressed air powered cars, rather than having a driving engine that is powered by fuel air, like air mixture caused by gas or oil, they basically use the expansion of compressed air, kind of similar in the manner to the expansion of steam in a steam engine. And then other than cars, ships also use air compressors to kind of start their engines. And also it's simply a lighter way of storage as well. So, and which means if they carry something like oil in their tanks, it's going to cause the ships to sink. So it's for the sake of minimizing their weights.
Okay, so now we get to talk about the benefits of compressed air energy storage. So we briefly mentioned batteries are one way to store energy, but the compressed air energy system has a significantly longer lifetime compared to a traditional battery. And obviously it is less wasteful because batteries, you have to get rid of them. They can create pollution. And generally, it's just cleaner to use compressed air energy storage. And as we mentioned, air is abundant all around. Technology is renewable. You can use wind power, you can use solar power, I believe you can use water power. So you can always renew it. So the storage allows energy to be saved for fluctuating demand. Say it's nighttime, energy demand is higher than because people are using lights, they're cooking dinner, something like that. But now with this higher energy demand, you have less energy because the sun is not out, the wind may not be blowing, something along those lines. And you need a way to be able to have energy to meet that demand so that it reduces your reliance on fossil fuels. And when you reduce your reliance on fossil fuels, you reduce the carbon dioxide emissions that go along with them. Pretty simple there. Another great benefit is that compressed air energy storage adds $23 per kilowatt year and $28 per kilowatt year in reserve revenue for conventional and adiabatic systems, respectively, in energy markets. Basically, what this means is that they create revenue over a different source of energy, a different way of storage, something like that. And having these reserves, the reserves is what you're storing up, is potential energy that wouldn't be used with a traditional system that you're now able to gain because you have these reserves. It's also cost effective. Compressed air energy storage can be put pretty much anywhere, as we mentioned, but it is most cost effective at a wind site, and it costs around $135 per ton of CO2, meaning that it saves quite a bit of money over another system. Now we get to look at the criticisms and the limitations of compressed air energy storage. So we talked about how compressed air energy storage and compressed air technology in general works on the basis of using heat to compress this air. With all this heat from the compression, you get unwanted thermal energy that reduces the efficiency of the storage and can cause damage to the entire system. Compression by nature increases heat, and sometimes it can do this to a level which can create a catastrophic tank rupture, which you can see in the bottom right corner right there. It's an exploded tank from a heat buildup that was not properly regulated. Another issue is that air compressed vehicles have to be compact and lightweight, which means they're not really feasible to carry heavy loads. So for this, think about your big rig truck that carries product from coast to coast and produces a ton of CO2 emissions. It seems pretty likely that, well, it's neither compact nor lightweight, and it will still be producing these emissions because this compressed air technology may not work for it. Compressed air energy storage is also considered unprofitable under most circumstances, as its main benefits are social benefits. So the social benefits are the benefits that society gets from having this technology. Compressed air energy storage is less cost effective in terms of generating revenue and profit than, say, a fossil fuel or maybe a different form of energy. But the benefits that come from having this clean air, clean water, renewable energy they do outweigh the cost, but in terms of pure profit, it's considered a risky investment compared to other storage systems. And that's all we have.
Okay. That was.
Just stop the recording.
Yeah, how do I?